Hi students, so today our topic is a depth first traversal in graph. So graph is nothing but a non-linear data structures. That means you can save the data without any order. That is known as non-linear data structures. Both tree and the graph is a type of non-linear data structures. So here the graph is represented by capital letter G, the combinations of vertex and edges. So vertex is nothing but to save the data. It is represented in circle format. So edges E is used to connect the nodes, one or more nodes to form a graph. This is known as direct graph and indirect graph. So in this diagram we have arrow mark in the edges, that is known as a direct graph. We have from and to connections. We know about from and to path. So when go to undirected, there is a no path definition. So where it starts and where it completed, there is a no definition here. But in directed graph, we know about which is the starting, which is the ending node. Okay. So next slide explain about graph traversal. So travel means visiting a particular place. The same concept is used here. The graph traverses nothing but is one of the searching techniques to visit or finding the path of a node or vertex. So the graph vertex must be visited at least one time. So graph traversal is used to determine the order in which it visits the vertex. So the graph traversal is used for searching process. The second one for to know the visiting order, to determine the visiting order for all the nodes present in graph. So the graph traversal have two techniques. The first one is birth first traversal and depth first traversal. Okay. So important condition in graph traversal is without producing loop. It never producing the loop while visiting the nodes in a graph. Okay, now we go to see about depth first traversal. So this is an algorithm starting from root node 2 and bottom of the node. So this algorithm starts at the root node and examines each branch as far as possible before backtracking. So you can take any node, you take or you consider any node as a root node. From the root node to its adjacent nodes to at end of the node. So from top to bottom we must visit all the nodes in the particular branch. Okay. So by using the stack, so how the depth first traversal working means we can implement the DFS by using stack data structures. So the stack is used to store the adjacent nodes of visited nodes. Adjacent nodes of visited nodes. Okay. We have 4 steps followed in depth first traversal. The first step, visit the unvisited vertex. Here you choose any unvisited vertex. Mark it as visited and push the visited node into the list. The list name is visited list. In step 2, so after completing one node, okay, the first node is visited. The step 2, we find the adjacent nodes of visited node. We find the adjacent node. Adjacent means the node connected with the visited node. Okay, we find the number of adjacent nodes and insert into the stack. The visited node insert in list. Adjacent nodes are listed in stack. The step 3, visit the next node. Visit the next node by choosing the top of the stack element. So the first node is visited and the vertex, adjacent vertex are listed in stack. Next I want to visit the second node. Where we can choose the second node means the choose from stack top element and visit it. And finally the visited nodes are insert in visited list. Okay, so repeat the step 1, 2, 3 until the stack is empty. Now we go to see one example. So this is example graph, the collections of 5 nodes. First the DFS start from 0. The visited node is 0. The first time visited node is 0. It is marked by sky blue color. The visited nodes are insert in the list, the name of visited list. Next I find the adjacent nodes of 0. So the 0 connected with 1, connected with 2 and connected with 3. So totally I have 1, 2, 3 or adjacent nodes of 0. So 0's adjacent nodes are pushed into the stack. The first step is completed. So next I want to visit the node 1 because the node 1 is top of my stack. The node 1 is my top of the stack. So I visit the 1. So after visiting the node 1, the node 1 is pushed into the visited list. Then adjacent nodes of 1. So the node 1 connected with 1, the node 1 connected with 2, connected with 0. So here I want to add these two adjacent nodes. But the 0 is already visited, so ignore. The second one is node 2. It's already present in stack, so you ignore. So next my top of the element is 2. So I go to visit the node number 2. So node 2 is visited and add in the list. The two adjacent nodes are 4 and 0. The 0 is already visited, so ignore. Now we want to push 4 in the stack. In stack we use only one pointer top element, store the last inserted in element at top. So my next element was 4 to visit. The 4 element is visited and the 4 is insert in the stack, insert in the visited list. The remaining and the final element is 3. Then 3 is visited in last and inserted into list. Now the stack is empty. At the same time in graph all the nodes are visited. So this is known as depth first search. So starting from 0, and the 0's adjacent nodes are 1, 2, 3. So we go to at bottom visit 1, the 1 connected with 2 and 0, then we go to connect with 2. So we visit the graph branch by branch. That is known as depth first traversal. So it's very easy when compared to depth first search because it have a very low time complexity and space complexity. The value of time complexity is collections of vertex and the edges. So combinations of verges and edges. Also the space complexity depends on number of vertex. Then final slide represent the applications of depth first search algorithm. So this search algorithm mainly used for visit all the nodes present in the graph and does not make a cycle or loop. This is the main applications of depth first traversal. It's also used to finding the path between the nodes and also check the graph is bipartite or not. Also we can finding the strong connection between the components. Thank you students.